Today I want to share a bit about how you can use the float from curve in Niaraga to make your VFX more interesting, and also some alternative ways that you can use that module. So first of all, I made this very simple Spark VFX. You just take a circle sprite, I gave it a spawn rate of 50, initialize its lifetime to 0.25 with a purple color, and some randomness in the size from 10 to 30. A shape location of sphere with the radius of 5, and then we add some velocity from point with also some randomness in velocity from 300 to 1000. For the update, we have some drag. I set it to a value of 5, and we also added this module that scales sprite size by speed. This is very important to make your sparks more interesting. So the min scale factor is what we will multiply our sprite size by when its speed is 0. And max scale factor is it's what we will multiply our sprite size when our speed is at this velocity threshold. So basically what we want is when the speed gets faster, we want our sparks to become thinner but longer in the lengths. This is related to like animation principles. So when you're moving something in speed, you basically want its shape to move to reflect its speed change. So the faster it is, we want it thinner and longer, and this module basically helps us do this. Now you can see it's kind of interesting, but it kind of cuts off each sprite at the end of its lifetime, so it just suddenly disappears at the end. So what we can do here is use this scale sprite size module, and instead of this uniform, we have uniform curve. And here is our first use of a curve for floats. By default, it sets its uniform curve index to particle normalized age. When a particle is born, that returns 0 to us, and at the end of the lifetime, it gives us 1. So how float curves works is it looks at the value you feed into this index. So if you give it a 0, it'll look for the value that's corresponding to where it's 0 and return it to you. So what we want here is to have our spark shrink as its lifetime goes by. So we can use one of the default curves up here, which is the smooth ramp down. And we can also do this in the scale color. So with the scale alpha here, we can search for float from curve, and also using the smooth ramp down curve. So now you can see our sprite is shrinking smaller towards the end of its lifetime, giving it a fade out. Now it's feeling a bit too short for me, so I'm gonna select the ending here on the scale sprite size and just move this handle upwards so our sprite size doesn't shrink too fast. So that's our first use of a float curve. And now I want to talk about another way to use this curve. So as you can see, our index here is usually particles normalized age, but actually we can use a different value for this and it gives us a different result. What we're gonna do here is in our scale color, we're gonna copy this float from curve. Gonna search for a multiply float and then paste back the float from curve here. For the other B input, we're gonna use another float from curve, but here the curve index, instead of the particle normalized age, we're gonna use emitter and choose the normalized loop age. We're gonna choose the last default curve here, ramp up and down. And now you can see that each particle in this emitter is being faded out uniformly and then faded back in because we're using the curve index of emitter normalized age. If I resume it to the default value, which is particles normalized age, you can see that we don't have that same effect where every particle is fading out together, because our curve index here is on a particle's level, which means that each particle is fading in and out in its own lifetime. But if we want every particle in this emitter to fade in and out together, we're gonna have to use the normalized loop age here. So actually this curve index here, you can input anything as long as it's a float type. So for example, if you just search for emitter, you can see you have age, current loop duration. There's a lot of inputs that you can use. There's also the same thing for particles. That's not just the normalized age. Basically, any value that is a float, you can put it inside here. So this makes the float from curve a very powerful tool to create VFX, which brings me to my third usage of this float from curve, which is kind of like a probability distribution. So now we have our velocity evenly distributed between 300 and 1000. But maybe we want most of our particles to be faster towards 1000 and just a small part of it that is 300. So how can we do that? So now our velocity, instead of a random range, we're gonna change it to a float from curve. Now for the curve index, we're gonna switch it to a random range float, ranging from 0 to 1. Now for our graph, we're gonna set our first key to the value of 300 and our second key to our value of 1000. Now you can't see where the keys go right now because they're way up high in the graph, so we can click on this zoom to fit all keys to get it back. And now you can see that our y-axis range from 300 all the way to 1000. So right now what it does is that the random range float now here evenly distributes between 0 and 1. It returns an output between this range. A value of 0 will map to 300 and a value of 1 will map to 1000 now. And then the rest is evenly distributed in between. So this is basically the same as using a random range from 300 to 1000. So now what if we want most of the particles to be slower? We can select both keys, right click, and change it to auto. So that gives us this extra handle and makes the curves smoother. Now if we want more of our particles to be slower, we can just move this key and change the time to maybe like 0.8. So that means 80% of our particles is going to be assigned a velocity of 300. And the rest, 20%, is going to be distributed between 300 to 1000. Now, vice versa, if we resume this back and we move the key of 1000 more towards the front, you can see that most of our particles' velocity is at 1000 now. Now, I kind of exaggerated the positions there to like show my point. But if we want most of it to be slower, we can simply just select the second key and just move the handle like this. So you can see when our curve dips down like that, most of our index is going to be mapped to a lower value with a few towards 1000. So that is our third usage of using a float from curve as kind of like a probability distributions when you don't want things to be evenly distributed between two values. That brings us to our fourth usage of float from curve, is to create a relation between different randomness. So what does that mean? Now we have our particles randomly distributed with a sprite size of 10 to 30. And maybe we want the smaller sprites to have a bigger velocity. And to make the bigger sprites feel more heavy, so we want a lower velocity with them. Right now, all of them are randomly distributed, so there's no relation between each of the randomness. Now we can use this float from curve technique again to create that relationship. Here's how we do it. We add a module, search for set, new, or existing parameters directly. We're going to search for a float, and I'll just call it random index. This random index is going to have a random range from 0 to 1, and let's make sure it's at the top of our stack. So now instead of evenly distributing from 10 to 30, we change it to uniform, and then we use the float from curve technique again. But the curve index now is going to be our random index here. And you can see a value of 0 maps to 10 here, and a value of 1 maps to 30 here. So now in our velocity, instead of this random range float, we're going to search for the random index again. But now we have a problem. You can see that the small particles actually have a lower speed here. That's because back in the initialize particle script, here a value of 0 maps to 10, which is the smaller particles. So in our add velocity here, we actually want this first key to be at 1000 and our second key to be at 300. And let's move our handles like this. So most of it has a slower speed. And now you can see our bigger particles are concentrated in the middle because we assigned a slower speed to it. And although we still are randomly giving each particle different size and speed, there's a relationship between the size because we're using the same random index here. We can even push this further to give it different colors too. So here, direct set the color. Instead of using a purple, we can search for the lerp linear colors here. We're going to start with the purple color, and then we can choose something like a light blue. For the lerp factor, we're going to use our random index again. Yeah, so now you can see in the center, we have our blue particles that are bigger and slower. And towards the outside, we have these smaller, faster particles that have a color of purple. And that is because we connected these three attributes by using the same random index here that is assigned each time a particle is born. So yeah, that's basically it for today to show you different ways that you can use the float from curve in Niagara. Now there's also a bonus tip that I recently learned is when you select multiple keys, it shows you multiple values here in the text box, right? But actually you can still do calculations here. For example, if I type in add 100, you can see it adds both of the keys up 100. So this is very useful when you want to just shift your whole curve. That's maybe you have more than 2 keys, right? Sometimes your curves can be up to like 5 keys with like complicated shapes, and then you want to like shift it left or right or up and down. Instead of selecting everything and just moving it by your mouse, which sometimes messes up your whole curve, you can use this text box calculation technique. Even though it's a text in the text box, you can still do calculations. So that's it for today's video. I hope you learned something new. Let me know if you have any problems in the comment area. Like and subscribe if you find this helpful, and I'll see you in the next one. Bye.